Hi, my name is Sarah Carbain.
And I'm Jennifer Mantioni.
Today, we will be discussing our Mathematics Orientation Seminar final project.
For our project, we conducted research on the history of Greek mathematics.
Specifically, we were interested in the effects that Greek mathematics had on the world of modern mathematics.
In order to understand the impacts that Greek mathematics had, we focused our research on specific famous Greek mathematicians.
Specifically, we focused on the works of Thales, Pythagoras, and Plato. Not only did their work impact mathematics, but it also influenced each other greatly.
Before we begin speaking about the specific works of the famous mathematicians, let's first discuss the foundation of mathematics. As we know, the world of mathematics is constantly changing. Because of this, the history of mathematics is extremely important. This is because every moment, finding, theorem, and so forth has shaped mathematics into what it is today. Specifically, the history of Greek mathematics played a major role in the development of mathematics. The ancient Greeks were a very advanced and civilized society. They were a fast-growing population, and their empire expanded rapidly. The ancient Greeks spread their sphere of influence into Asia Minor, Mesopotamia, and beyond. As the empire expanded, the Greeks adapted elements from the societies that they conquered. Specifically, the Babylonian and Egyptian empires played a big role in shaping Greek mathematics. By the Hellenistic period, the numerical system was established. This system was very similar to the Egyptian and Roman numerical systems. It was a base 10 system with symbols for 1, 5, 10, 50, 100, 500, and 1,000. It repeated as many times needed to represent the desired number. The Greeks used this numerical system to add, multiply, and divide, starting a mathematical breakthrough.
Although the Greeks did a lot of work with their numerical system, their main focus was geometry. The ancient Greek mathematician Thales was the first person to distribute guidelines for the abstract development of geometry. Most of his work had to do with similar and right triangles. One of Thales' most famous theorems is the intercept theorem. In the article, Learn About the Intercept Theorem, Geometry Theorem Proofs of the Intercept Concept, Suvo sums up the theory as well. He states, the theorem states that if two or more parallel lines are intersected by two self-intersecting lines, then the ratios of the line segments of the first intersecting line is equal to the ratio of the similar line segments of the second intersecting line. Here's a visual representation of this theorem. As we can see, the diagram depicts that DE over BC equals AE over AC, which equals AD over AB. Now let's discuss Pythagoras and his works.
Pythagoras played a significant role in the history of Greek mathematics. Believe it or not, most of Pythagoras' work was connecting mathematics to philosophy. Pythagoras believed that the sole explanation of all things could be found through numbers and form. Like Thales and other Greek mathematicians, Pythagoras was very interested in geometry. Now, I am sure you've all heard of Pythagoras' theorem. In the article, Pythagoras' theorem from mathisfun.com, this theory is defined as when a triangle has a right angle, 90 degrees, and squares are made on each of the three sides, then the biggest square has the exact same area as the other two squares put together. More commonly, this theorem is written as a squared plus b squared equals c squared. We can see this perfectly from the following diagram. As we can see from the diagram, the sum of the sides 3 and 4 is equivalent to the square of the hypotenuse 5. Now let's look at someone who was greatly influenced by Pythagoras, Plato.
Plato took the works of Pythagoras to the next level. Like Pythagoras, he believed that numbers were the key to reason. In fact, Plato believed that he could figure out the secrets of the universe through geometry. So he created the Platonic solids. The first shape that Plato identified is the tetrahedron. The tetrahedron is constructed of 4 regular triangles, and it is a shape that Plato represented fire with. The next shape is the octahedron. The octahedron is composed of 8 triangles, and it is the shape that Plato represents air with. The third shape that Plato identified is known as the isohedron. This shape is composed of 20 triangles, and it represents water. The fourth shape that Plato identified is the hexahedron. The hexahedron is composed of 6 squares, and it represents Earth. The fifth and final shape that Plato identified is the dodahedron. The dodahedron is made up of 12 pentagons. This shape represents the god who arranged the constellations of heaven. Here is a visual of each Platonic solid. As we can see, Greek mathematics played a major role in the development of modern mathematics.
The works of the famous Greek mathematicians will continue to inspire future mathematicians in the years to come.
We hope you enjoyed our video.
Thank you for watching.